Hello everyone, my name is Hisham. I am the owner of Clemson Aeronautics, where we make the riveting and dimpling systems. I apologize, it's been a long time since I put out a video, and because of the just tremendous orders that we got during the last sale, and I just finished shipping the last machine yesterday to British Columbia, and thank you very much for all your orders, and watch out for another sale coming up soon. Last video, Building Essentials 1, was talking about the whole preparation. As you all may know from the last video, that good airframe requires good riveting, and good riveting really relies tremendously on the dimpling and hole preparation that you're going to have for it in the process. So the hole preparation we already discussed in the last video. This video we're talking about countersinking and dimpling. So let's start with the countersinking, get this one out of the way. Although there is a lot of information, but not as much as the dimpling part. Countersinking, you're going to use a tool very similar to this, or like this. And the job of this tool is that you set it, because it compresses. So you set it where when you are pushing your drill or drill press, it exposes just enough of the cutting tool to create that countersink, just deep enough for the rivet to sink in. Now, if you go too deep, you cannot undo that. So you have to be careful. That's one thing. The other thing is perpendicularity of this tool. That's why you have this surface here is directly perpendicular on the moving action of the tool. So if you are using a hand drill, you need to try to make sure that you are perfectly perpendicular on the material. Better yet, use a drill press whenever you can. There's a lot of things that that you're gonna countersink that you can use the drill press for, and that is my go-to tool. First, I can control the speed a little better than the hand drill or a cordless drill. And the second thing, I already have a table that's perpendicular on the movement of the tool, so I don't have to worry about that. But what I do have to worry about is in occasions like the horizontal stabilizer, the spars, I had to make some kind of fixtures from wood to hold it in a position where the surface of the material that I am countersinking is directly flat with earth, and we can go down with the tool, and it's easy after that. Once it's set up, once you make a some kind of a fixture to hold it, it's a done deal. Just don't go too deep, because you cannot undo that. So it's best if you go shallow and then adjust it just a little bit at a time. What's a little bit at a time? If you try it and it is not nearly as deep enough, I would go a few clicks on here. Speaking of clicks, you guys, I hope you can see, yeah, I think you can see that. These teeth here, when you compress that, you can turn that. So this turns. So when you turn it like this, the tool goes deeper because you're literally moving it down. So the tool can go deeper into your material. Now, when you do it the other way, or like facing it to be counterclockwise, you're going out with it. So whenever you push your tool, it doesn't go as deep. Now, each one of those teeth, when you move it, it represents a change in depth of 1/1000th of an inch, 0.001 of an inch. And that is good news, so I can adjust it perfectly. Then you need to tighten that nut here. There is folks out there that find it difficult to adjust. So what they do, they buy 2 of those. Adjust one for the number 40 rivet and another one for the number 30 rivet. That's fine and dandy. But you will get to areas where the hole is close to a wall or something like that, and you want to kind of sink it. You have to kind of cut. You see how I cut the edge right here? So you can get close enough to a wall to be able to countersink something. So this is a third one that you cut. Another disadvantage with this tool, you don't have that big surface that you have to make sure that you are perpendicular and it sits stable. It kind of rocks a little bit, so you have to watch it. If you cut your tool, you have to try to make it perfectly perpendicular somehow. Now, what material can we countersink? The book says, our manual says, don't countersink any material that is less than 40,000ths of an inch, 0.04. So why is that? Is because to get the rivet flush, you're gonna have to go so deep with it where actually the existing hole is gonna be a part of that cone shape, and the hole itself will get bigger. So you adjust the hole at let's say they call for number 40, which is 0.098. Then you countersink it on a thin material. That 0.098 could be 0.110 because you got so deep in there. So you have to watch out with thin material. How careful should I be? I'll tell you how careful should you be. A perfect example of that is the horizontal stabilizer. The spars on the horizontal stabilizer have to be countersink to match the skin of the horizontal stabilizer. So you're not actually matching it to the rivet. It is a rivet that's going in a skin, and then the rivet and the skin going in another countersink. So the material itself of the skin is included in this equation. So you have to go deeper if you want the skin to be flush with the spar. So what do we do here? It's in the manual, guys, but I'll go ahead and tell you that you have to be really careful. And they are correct. I already made my horizontal stabilizer, you guys know that, and I did what they said in the book, and it worked out beautiful. So don't overdo it. Don't think that I can go a little deeper and stuff. No, don't try it. It's best not to try. So how do you countersink the spars to accommodate the skin with a dimple? The book says countersink it to accommodate the number 3 rivet. I think I managed to get the rivet here. Well, I also managed to lose. Ah, here it is, right in front of me. This is the number 3 rivet. You have to accommodate the dimple of the skin goes in the spar, in that countersink of the spar. So you start, I'm sorry, let me start this again, and I'm not going to edit, so please excuse me. You countersink the hole to match the rivet. So you adjust your tool, you countersinking, you keep on adjusting till that rivet goes in there and it is flush. After that, you go 7 thousandths deeper. How do we achieve the 7 thousandths deeper? After it's adjusted everything and the rivet is flush and everything, I'm gonna go like this. I'm gonna pull this out, and this is where you see these marks. Like we started right here. So I'll pull it like this and say 1, 2, 3, 4, 5, 6, 7. That is 7 thousandths deeper because I screwed it in. So now this will, and then tighten the nut, guys. You need to remember that, guys and girls. So now this will go 7 thousandths deeper. I tried it. I have my horizontal stabilizer built, as you can see right here. And it worked out good. I mean, there's hardly any space at all between them. We have to consider priming. When you are dimpling, you don't have any choice as far as the depth is concerned, because the die is what's going to determine the depth. But when you are countersinking, you're the one that's going to determine the depth. So you have to bear in mind the primer. And speaking of primer, I happened to see a gentleman that is building an RV-10, and he was building his horizontal stabilizer. So I just naturally, I was curious. I wanted to see about the RV-10 and how it's built and so forth. And he was seemed to be a very nice guy and knows what he's doing. So one of the things that he was doing, he was working on the doublers, I believe. So if I'm not mistaken, he was working on the doublers. And he tried to get the rivet after he primed it, and now the hole was too tight. He said, I don't want to push the rivet in there, and he was afraid about the thickness of the primer also, and he said he didn't want to go too deep on the countersink. So he took the tool, the cutting tool that is used for countersinking, and he took the tool and he put it in the hole and turned it, and he said that was to shave the primer. And then after that, the rivet went right in. Well, there's two things to say about this. First of all, you took the primer off. This area between the rivet and the skin, there is no primer in it. The rivet have some anti-corrosion on it, and that's why it's yellow or gold color. So how about the skin or that spar? It doesn't have any protection whatsoever, and this is a primary area that we have to look for as AMP for corrosion. Streaking is, Google streaking on that. You find like a black, like black smoke coming out where the rivets is. This is corrosion. And it's an area where it's easy for moisture to build up and stay there. Guys, when you prime something, don't scrape the primer off. And if you happen, and you're going to do that with the horizontal stabilizer because you're going to prime everything, then you're going to go in there and rivet and stuff like that, and your bucking bars will scratch the primer inside. Just go in there with a can and lightly coat it again in the areas where you scratched. This is good, so your grandkids will fly that airplane, or somebody else's grandkids. So primer, you don't prime something that's scrape the primer off. That's not a good thing. Also, there is a lot of people out there that I saw that primed their spars, then countersunk them. So how are you going to do that? Are you going to prime it again? I didn't see him priming it again before they riveted, and then again I wasn't there. So might as well not prime it at all before you countersink. I prepared my horizontal stabilizer, guys. Okay, my horizontal stabilizer, my rudder, my vertical stabilizer. I prepared every single part completely, match drilled, final drilled, everything. When it was ready to be put together, that's when I stopped and primed everything, then started riveting. The only thing that was left was riveting after priming everything. So there's a lot of guys out there that would do the spars on the horizontal stabilizer and leave this countersinking all the way to the end, right before they start riveting it together, and then they start countersinking them. So what are you going to do there? Are you going to prime it again? I mean, you're doing something, either you're doing something twice, which is not necessary, or you're not priming it at all, which is not good. It is important inside a countersink. That is very important to be primed, guys, because this is a very, very critical area. Moisture will build up in there and it will stay there. So those are the important things when it comes to countersinking. Most of the time, so far in my build, I used my drill press to do the countersinking. It was easy and it was accurate and it gave me a really good result. So if you can, stick with that and get a drill press that you can go down with the RPM to like 200 or 250 RPM, so this thing is not ripping around at 700 RPM. That's just too much. So that is that for countersinking. Now, as for the dimpling, you don't have much control on that except in one thing, to make sure it's pressured enough to create that dimple. So let's start the portion of dimpling with just a little bit of a thing that kind of upset me a little bit. I hate it when somebody try to put in new terms that other people that is not experienced don't know, to kind of scare them into buying their product. Oh, you're gonna have to have this in order to do this job. And this is one of those things which I really hated the way they talk about it. I feel like I've been had. And I don't know what the background is. Evidently, there must have been one company that made those dimple dies. And then when another company showed up to make dimple dies to compete with them or something, either one of those companies said the term flex back. And let me make sure of that term. Spring back. That's the term they're using. Spring back dimple die. For somebody that doesn't know much about dies and machining and so forth, they're gonna say, wow, yeah, I need that spring back dimple die and stuff like that. If you didn't know, I got some news for you. If it doesn't spring back, it's not a die. Folks, any die in the world that makes a spoon, it makes anything that's die, that's compression like this here, when you bend something, you have to overbend it to a certain point. So when it comes back to the shape that you want it to be in. And if it does not account for the spring back, it is not a die. So evidently they were scaring the customers into believing that their die is the one that is the correct, is like the other guys doesn't spring back and your airplane is gonna fall apart and stuff like that, or it's not gonna look good or what. Don't be fooled with that word, okay? So having said that, you need to compress it strong enough so the dies would meet completely, so when it comes out it forms the dimple in the correct way. Which brings us to a point, which is when you're using your manual machine or our system, the jaws is big jaws. So when you push that handle down, you want to push it down so hard to the point where the upper jaw, you can see it rise a little bit. That makes sure that you put enough pressure on that die to form the dimple correct. That's called preloading. So, and the same thing in our machine. You do it, you pull it. Of course, our machine is a lot easier than that. So you pull the trigger, and it goes all the way down. You can see the upper jaw just moving up ever so slightly. So how do you do that? You put the material, when you adjust it to the point where you have to go. On our machine, it's half a turn beyond when it's touching just the dies without material. Now, when you put material in there, obviously it will go even a little bit more, which is the size of the material. So if it's 16,000 or 20,000 or 25,000, it's going to go about. So the thicker material requires more pressure. So that's why we keep it at half a turn, regardless of the material. So now what do we do? You need to use also your squeezer in the areas where it's difficult to reach, that you cannot use a machine like this here on. The second thing that you have to be careful with is some ribs. The wall of the rib itself is so close to the hole. If you use the standard die, it will be pressing on the curvature that's next to the hole. So you have to use the reduced size dimple die, reduced size female dimple die. And this is a comparison between them. This is the reduced side, this is the normal size. When you are using a machine, whether it's ours or anybody else's, you want to make sure that the table you're using it is level, so you can get perpendicular movement of the dies. That is kind of important. Now, if you're going to use the squeezer, it's your job then to make sure it's perfectly perpendicular every time. Because if it's not, it actually does dimple it a little bit crooked. You can't see it. But if you using the squeezer, you will dimple one this way a little bit, the other one this way a little bit, then the other one the other side, and so forth. The result is not going to be a very good surface after you rivet that surface. One of the things that is affected by dimpling is the size of the hole, and I talked about that God knows how many times. So you guys be careful when you dimple something. Don't just go to town. Dimple one and check it with a caliper or something, or even if you put a rivet in there and kind of move it, see how loose it is. So you make sure that this is not going out of hand. Now, in planning, when you are going to dimple a surface like the rudder or the horizontal stabilizer or a vertical stabilizer or whatever, you're gonna prime it. So when do you prime? Before you dimple it or after you dimple it? Priming before you dimple, it will pack primer in your die, and you have to stop and clean it up to make sure that it's cleaned up. Because that primer is going to be just hard as this metal, and it's going to stop producing a dimple that in the perfect shape like this die. So if you decide, okay, I have the holes prepped and the holes is in the perfect size and everything, and now I need to dimple. But before I dimple it, I'm gonna go ahead and prime it. So I scuff it. I scuff the areas where I'm going to prime. Then I prime it, then dimple it. Then you pack the primer on your tool. I think which worked for me best, and you can look at my tool, is perfectly clean. And believe it or not, I never cleaned it. I never really had to clean that one. Even inside, because this was always, because I'm using a machine, this was always on top. So the way I do it, that I found with all of this, the easiest way to do it is to get my hole prepped correctly, everything is ready to go, then I scuff it really well, because if I dimple it first then scuff it, it will just tear my pads, my 3M pads, the Scotch-Brite pads, like a shredder. So what I do, I scuff it first, then clean it up, then dimple it, then clean it up, because cleaning up with alcohol is really easy. So clean it up, then I would prime it. Now I have it dimpled and primed, and I don't have any issues as far as the dimple dyes packing up with primer material or anything. And at the same time, I did not ruin my Scotch pads. And it would be more difficult. There is a couple of times where it was only like 4 or 5 holes that was dimpled, and I went ahead and dimpled them, then scuffed it. And it really did the number on the little Scotch-Brite pad that I had. But this is the best method that I thought that would be that worked out great for me, is to get the whole prep, scuff it, clean it up, dimple it, then clean it up again, then prime it, then leave it to dry, and I'm ready to rivet. Folks, I'm working on my rudder right now, and of course there's something have to be done with this, and I don't know what. And let's check it out. This is 40 thousandths thick, which they say in the books this is the minimum that you can countersink. But unfortunately, and I can foresee that coming, that when I countersink that, I have to countersink it not for the rivet. I have to countersink it for the skin. So the skin will have a dimple, and that dimple would sink inside this. How I'm gonna do that? I don't know yet. I have to experiment with that. So you guys have to, when it comes to that, you have to wait till I get the video out for the elevators, so you can see what the end of this experiment is going to be. I mentioned before the machines, the manual machine or our machine that utilize the squeezer will flex a little bit while you're dimpling, and this is normal. So as the yolks. This is our yoke. This is our yoke. This is our competitor's yoke. We're a lot thicker. We flex a little less, but our nose here is a little thinner, and that is not affected at all as far as flexing is concerned, or strength. So both of them will flex. Ours a little less than others, so you have to be careful when you're setting up to dimple using a yoke. There will be some flex. Now, when it comes to our rib dimpling tool or rib dimpling options, our rib dimpling option have no flex. So it doesn't matter how much pressure you put on it, there is nothing to flex. It only compensates for the little bit of play from the pins, and these pins and those pins. And once it's stretched to the limit on those pins, it doesn't do any flexing. So when you adjust this one, you need to pull the trigger where it comes down to meet each other, and that is your setting. You don't want to turn it a quarter of a turn or half a turn or anything like that. I think if you have it touching each other, maybe 1/8 of a turn will be okay. Then when you put the material, that material is what's gonna give you the good punch in there. Now, you start and do one, and immediately take a rivet and put it in there. Make sure it's nice and flush, there is no gaps or anything like that. If it is, continue on and keep an eye on it. If it's not, another 1/8 of a turn and redo it again. So don't go too much on that, because you're going to be putting all 3,000 psi into this on your material. So you really don't want to expose the material to that kind of pressure. It's not meant to do that. So that's as far as our rib dimpling option is concerned. Well, folks, for now, this is all I can say about dimpling for now. Please don't forget to fill in the Vans form. This is our number, and this is our builder's number. And if Vans send us a check, that's going back to you in the form of, you can call us up and order something, or we give you credit back on something that you actually bought, one of the machines. So if you bought the machines for $550 and we got $100, we credit back your credit card $100. Please don't forget to, if you like our videos, please click on the like button, and please do subscribe. It helped me and it helped other people that's building RVs out there see our videos and maybe benefit from it. At the end, I would like to thank you very much for watching, and we'll see you next time.